Heard you wanna make a difference. No more wanna keep your distance. No more wanna keep your distance. Tired of being assistant. Tired of being assistant. If you wanna make a difference. If you wanna make a difference. Only love can find a difference. Only love can find a difference. Heard you wanna make a difference. Heard you wanna make a difference. So you're part of the resistance. So you're part of the resistance. Though we're living through persistence. Though we're living through persistence. Put a number on for instance. Put a number on for instance. Won't really stop existence. Won't really stop existence. As you wanna make a difference. As you wanna make a difference. Only love can find a difference. Only love can find a difference. Heard you wanna make a difference. Heard you wanna make a difference. Only love can find 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 a difference.
I swear that you've seen me. Yes, you've seen me here before. Before. And so don't tell it. Don't tell it otherwise. This voice, this particular voice, yes, you've heard it before. Before. And so, don't you dare tell it. Don't you dare tell it otherwise. No wonder why the road seems so long. 'Cause I had done it all before. And I won. You felt this feeling, tell me, don't be ashamed. You felt it before. Before. And so don't tell me otherwise. I almost forgot. Foolish me, I almost forgot. Forgot that where I'm from, we see the rain before the rain even starts to rain. No wonder why you've been bugging me. This walk, it's a previous journey. And I won. Before I was born, there was a storm. Before that storm, there was fire burning everywhere, everywhere. And everything became nothing again. And then out of nothing, out of absolutely nothing, I, Benjamin, I was born. So that when I become someone one day, I'll always remember that I came from nothing. No wonder why you've been buggering me, 'cause this walk, it's a previous journey. And no wonder why the road seems so long, 'cause I had done it all before. And I'm sending my condolence. I'm sending my condolence to I'm sending my condolence. I'm sending my condolence to insecurities. You should know by now. You should know by now that I just don't care for what you might say. Might bring someone downhill. I'm sending my condolence. I'm sending my condolence.
Hello, it's Mairead Maher here, and this is our Monday, our first of two topics or lecture sessions this week, and just ironically there, the song that was coming out or should have been coming out was Condolences. So sorry about the delay, but I don't think it's exactly a condolence issue, but maybe it was. So just a few glitches there with the stream. Thanks to Siobhan for sorting that out. And so yeah, we're ready to go. I see there's a few questions coming in on Slack. Siobhan is on Slack at the moment, and she'll talk to you about those. Sorry, the mic is probably better there. And so we're going to start this week, and I'll just pull this over here. So you can see there, I'll just put on this. Okay, so this you should be seeing here now. And okay, so the lectures will be coming up. There's issues about updating things at the moment. So I'm just going to show you what I have here. And so okay, so we're going to start then. We'll just start off and we will see that. Okay. So we're going to look, first of all, okay, so last week you looked at arrays, and so we're back to objects. I know we were using objects to a certain extent. We were using the arrays, but we're kind of using them in a not so objecty way, if you know what I mean. So before we get on to what we're going to do today is we are going to build up to having an array of product. Okay, because obviously in a kind of a grown-up world, we'll need to have many products, and this is the way we're going to model them. Okay. Also, what we're going to do today as well is we're going to do a little bit on validation. Now, I know there were some questions over the weekend about that, so we're just going to take it and do a unit on it. So we're going to take the basic version of product and we're going to validate. I'm going to implement validation and all of that. And there'll be exercises on that. So by the end of this week, you should be well able to do validation. You should understand what it's about. You should understand the why it's a good thing and so on. Okay, so before we start that, we're just going to do a recap of what we have done so far. So today we're going to look at a recap of classes and objects. Then we're going to look at specifically we're going to look at the shop version 1 that we would have seen before you kind of sidled off to the arrays. So remember, a class is a group of related methods and fields. Sorry, just give me a moment there. Better. And fields. So what we do is we get an entity. We say, is that entity an important entity in the system we're looking at? And if so, we're going to gather everything we need to know about it in a cohesive fashion. So an example of a class here, we always use the example, the string example, because that's a class that somebody else has written, but we use it a lot. So you can see here, this is our API, what we call the API. So you can just look up Java string library and you will get this, and it'll give you everything you need to know about string. Now we will talk about creating that for your own classes, but for the moment, we'll just have a look at this. So these are all the library methods that we get with that. And you can see over here, we have things like caret. The ones that would be very useful to us would be length. And so that's up at the top here. Caret we use a bit. Caret, if we put in a position there, it will give us the character at that position. This is actually useful because what we sometimes do is we want to see what the first letter of a string is, and we just do caret 0, and that gives us back that character. So an object is a single instance of a class. It's an object created from this class. So just say we've seen the string now and we know it's a class. So we want to make an object of this class. And what we have here is, you can see here it's building it up bit by bit. So when we say string A, we make this box in memory that's expecting a string. But differently to the primitive types, we don't know how big it'll be. See, if you have an int, I'm just going to hide myself for a moment. If you have an int variable, you know it's going to be how many bits it's going to be. All right. But in string, it could be a low or it could be a low there. So to get around this kind of anomaly, instead of just having all the data in the box like we would have in an integer, we basically have the address of the 0th or the first character, which would be H in this case, and then everything contiguous after that is part of the string. So that might be a hex version of an address, and we're saying that at that address, you know, it looks like hello is there, but actually H will be in that address, then E will be on the next, and so on. So that's one string that we have, but of course the whole point of this is that you can think of the class as a template, and the template is a single class, and you can make as many objects as you like from it. It must be uniquely named. Now, naming is a kind of it's a movable feast in a way, because sometimes we have a name like we called it string in the previous one. In the later on, when we're talking about arrays of objects, we can just, the name of it is the array and the index of it, as long as we're able to access it uniquely. Okay, so that's what we've seen with the objects. So now we're going to look at our shop version 1. And we've 2 classes in this. We have the driver and the product. And again, I know there was questions about driver and so on. And we'll address, I'll address those when we get to that. Firstly, we're going to say, right, what is the shop? And the shop is a system where we can have one or more products. Okay, you wouldn't have a great shop if there was only one product in it. But we start off just by having our product class and just creating one product object. Okay, we can see that as what we call sometimes a minimum working example. So we just want to see that the product is instantiatable, if you like. So this is just a drawing. It's just a way of saying, of showing that there is a driver and a product in the system, in the program. The product is what we're going to look at, and you can see there we have our little picture of our products, and they can be any product, of course. So we're going to look at the product in the rest of this slide deck, and then for the next slide deck we'll talk a little bit about it, but we'll do more about the driver in the next slide deck. Okay, so we will have seen this, but the product class stores detail about a product. Now, we've, as always in the case, this is not a real world example. We just want to give you an example of loads of different types. So we have a name, a code, a unit cost, and a Boolean. So the name is a string, the code is an integer, the unit cost is going to be a double. And it's just to get you used to the different types that are there. So in the driver class, we're going to do a little bit more about it, but the driver class is our new name for what we would have called main up to the previous, iterations. And we call it a driver because it's not as obvious now, but we're going to use the driver as the kickoff point. It has the main method, the kickoff point to everything in the system. Later, we'll see that we'll kick off our menu from there. But for the moment, it's a very, very basic driver. We just say, read in the product, create the new product object, and print that out. So it's quite contrived, but it just gets us doing something. And we'll do more about that in the next lecture. Okay. So now we're going to look at product. And just remember that we have looked at product before, and we'll just have a brief recap of it. So we have our name, and you can see there in the UML diagram that this is C for class. The open lock means it's public, because there wouldn't be any point in having a class that wasn't public, because we need to be able to access it outside. That means it's a class, that means it's public, and product is the name of the class. These are the fields of the class. You can see F means F for field. Now, just to note that kind of intuitively, you may think of the fields being at the top. Certainly I do, but just with the UML, they put them at the end. So, because when you're declaring, you'll do that up at the top. So these are the fields. The close padlock means it's private. We've said that we need to have all our fields private. This is our golden rule, all fields private. So you can see the padlock is closed there. And this is our field name, and this is the return type. Or sorry, the field type, excuse me. Okay, so you can see there we have a good a range of types, and that's deliberate. So we've string, we've int, we've double, and we've boolean. Okay. So the first method we see here is a constructor. And this is how we instantiate or actually create a space in memory for the product object. And we can write a number of these constructors. A kind of a usual one is if you have 4 fields, that you will have a constructor that takes in those 4 fields and assigns them to each of the fields. Now, what's special about the constructor? Well, the ordinary thing is that it's a method. It just is a special method. It's public. And it's a constructor if it has the same name as the class. So product, you can see there. Okay. And there's 4 parameters, 1 for each field in this. Okay. So what do we do with that? That's what it looks like. That's the statement. Now note also, there is no return type. It's the only method that doesn't need a return type. So 2 things about the constructor. It's the same name as the class and it doesn't have a return type. So this is the code for the constructor given the fields. So here are my fields. Here. And you can see here string product name. We're doing this very basically. We're going to improve this in 2 slide decks time. But for the moment, it's just product name, product code, unit cost, and the Boolean in current production. And the constructor is very basic, but what it does is, and remember, that what this does, we would have, remember that this dot product name goes into that, okay, product code, unit cost, and in current production line. Okay, so you're just taking the values from the parameter and putting it into the field. Product code goes into the field product code, and you can see the colorings there will tell you what matches with what. Okay, so that's the constructor. We'll come back to the constructor later, just to improve it, but that's the basic constructor. Now, the next one are the kind of, we call them POJO or plain old Java object methods. For every field, you need a getter and a setter. We'll see the benefit of this later on, right? You really haven't seen the benefit of this so far. You will see that today, hopefully. So these are all the methods, in other words, the getters and the setters. Now, just note here, one thing, kind of a derivation, is that for all of the fields except Booleans, you call the getter get x, where x is the name of the field. If you think about what Boolean does, instead of saying get in current production, you just say is in current production. And just think of the way that will read. So instead of saying if get, you'll be saying if is, and it just reads better. We also have the toString, and we'll talk a little bit about that as well. Because sometimes we'll be talking about generating code, but the basics of these, including the constructor that we just saw, they can actually be generated. They're so mechanically derived, if you like. So again, the M icon means it's a method, and the open padlock means it's public. In general, as a rule of thumb, always make the methods public and the fields private. Sometimes you can change your methods to private if it's only being used, if that method is only being used internally as a kind of a little utility method. But for the moment, just keep it simple. All methods are public, all fields are private. Okay, this is our method name. That's the return type. And you can see there's no return type on the constructor, as I said on that. These are all my getters, including the is, remember, for the Boolean. So what are they? Just a brief recap on it as well. It's like taking a photograph of the flower. Do you remember we talked about the flower? And if you didn't want to, sorry, my camera is a bit glitchy. So if you didn't want anybody from the outside to be able to access the flowers, you didn't want people trampling on them, but you wanted to be able to see them. This is a way of almost taking a picture of the flower without having access to being able to trample it. So most people, you would hope, should be allowed to take a picture of it. So what we do is we just say that's a public method, so anybody can do that. Anybody can get the current value of that. And accessors in general are just any kind of method that just reports or takes a photograph of any state value. The getters are a particular example of this, when they just simply say, you've get X for the field X and so on. So it contains nothing else on your return statement. There's very little logic. There's no logic in it. Just be really careful not to put logic in it, because there's no need for it. It's just taking a photograph. You're not asking it to pose or anything. You're just saying take the photograph of it. It defines the return type, and it doesn't change the object state. It's like taking a photograph. So very simply here, if I'm trying to get unit cost, all I say, this is the start. Even if there's only one statement, you still need your start and end method body. That's not the case if you're talking about an if statement or a loop. If there's only one statement, you can leave out the curly brackets. I'd say put in the curly brackets anyway, just while you're starting. This is the method name. The parameter list is empty because you don't have to give it any data. You're just saying unit cost, that's the value I want. This is the return type, which should match with what the type that unit cost is in the field declarations. And the visibility, who can see it? Everybody can see it. So everybody can take a photograph of the value of the variable. And this is my return statement. Return statement has two functions. It returns the value. So this double here is promising that the answer will be a double, and the return actually allocates the value to that. It says, yeah, I know it's going to be a double, but this is a value that's going to go back. The return then also, so it gives the value to the function call, but also it terminates the method immediately. That's not significant here because it finishes anyway, but in other ones it will be. Okay, and these are the four getters. So you can see here, in all of them, note, it's get product name, return product name. Get unit cost, return unit cost. Get product code, return product code. And the is, remember, is different here in product line, return in current product line. All right, and they're all public. So they can actually be generated, and we go through this in the lab, one of the labs this week, how you can actually generate code, and it's really handy actually. But you need to understand what's happening there before you go generating. Okay, so the next thing we look at then is the setters or the mutators. So you can see here set, again, we use the same kind of naming convention that it's set and the name of all the fields. In this case, there will be parameters because you're sending in values, and those values are the ones you wish to change and to update the values of the fields with. So they're void, it doesn't return any value explicitly, but it does bring in values that you hope will make the changes to the field here. Okay, so mutate means to change, so it changes the object state. And the setter, again, like the accessor and the getters, the setter is a particular kind of method, and we basically, they're default ones for each of the fields. It contains an assignment statement. It takes in a parameter of the value we want to update it with, and then it changes that that state. So you can see here, it's public again because you need everybody to be able to do it or use it. There's no explicit return value. We call this later on in programming a side effect. It doesn't actually return a value, but it does something significant. Okay, and we always need to be really careful when we're changing the value of state. In a way, the getters are kind of safer. Even if you mess them up, you might have a bad value, but you're not going to change the data. You now have, in the setter, you can change the data, and that's what you want to do, but you can mess data up as well. So you have to be an awful lot more careful with the setters. This is our method name. This is our parameter. We're trying to put this value of unit cost into the field. And this is the field being mutated, and we're going to use the this dot, which is the field value, and the unit cost on the right is the value coming in from the parameter. Assignment statement, and the value passed in as parameter. Okay, so these are all the setters here. Now again, these are very basic, and these are what will be generated for you if you try to generate them. And the point about this is you're not actually getting any benefit from just having that code, because it's just throwing in the values without seeing are they okay or whatever. And that's what we'll be looking at in 2 slides time. Okay, how to actually improve this. But for the moment, it just takes the product code and puts it into the field. Okay. So we expect that you will write a getter and a setter for each instance field. And again, if you do a generate, that will give you, just select all the fields and do that. Then you can improve those when we get to that. We also expect a toString for most classes, except the driver actually. Let me see why later. So the toString object, we will want often, we have getters now, so we can peer in and take a photograph of the particular fields. But if we want, oftentimes we want to get a snapshot or a nice version of what the state of the object is. And instead of building it up every time, we code it as a toString. So whatever is in this toString, you can use that to actually give me a nice version of what the string is. So we'll see what we do in the generator one, the simplest one. It'll just return, and it'll say, now remember this is written in the product class, so it has access to all of the fields. So this is going to get printed out as product description and the current product name, product code, unit cost, and this. Now, in this one, it's going to come up as true or false, but we'll see what comes up and just have a look at that and make sure. Now, we have a very, very, very small TV, so but you can see what's going on there. This only returns a string, so it returns a string version of an object. And we can use this, you see, you could go, every time you wanted to print it, you could print, you could system.out.println product.get code, get and thing, but we do it all together here, and we have a kind of a predefined toString, and you can make that as nice or as plain as you want. Okay. Now, so toString is really important in our things, and we call it one of our POJO. It's a real, you need it in all of your classes, as I say, except driver. So when you print an object, and what does that mean? Your Java automatically calls the toString. So when you say, if you say product is equal to new product, both of these will do the same thing. So really what you're trying to do is say product.toString, and that will call the toString that we've just written. But because toString is a special name, and because of other things that are going on behind the scenes, like inheritance, that we will cover eventually, it will look for a toString there, all right? And so it looks for a toString. Now, what happens if you don't have a toString written? There is one, a default one there. So if you ever see kind of an address or something like that when you think you're going to get a toString, just check, because it means that it can't see a toString. So you might have misspelt it. It needs to be spelt in exactly that way. Okay? So just the encapsulation then in Java. Remember that we want to have a cohesively, nicely written product class. The first thing we need to do is everything that we need to know and do about the anything product, any product. We need to have the fields here. We need to have the constructors and the methods. So we have the data. We have how do we create one, and then we've all the methods that change it or report on it. The next thing we need to do is to declare the fields from the other classes. And again, when we look at the validation later today, you'll see why that's important. We don't want somebody coming in and trampling over the flowers or changing the value of a field to something that does not make sense. Okay? And then we can only access the fields through the methods of their current class. So we provide the public, and very simply at the start, all our fields are private, all the methods are public. Okay, so this is an example. So product class wraps all the data and the methods into the single unit. The fields are hidden. And we access the fields only through the methods of the product, getter and setter. Okay? And toString, of course. We use toString to actually print out the values. Okay? So, when we're declaring an object of type product, in the same way as if you say int x, it'll just give a default value. The default value for an object is null. In other words, it's like having a letter with no address on it. It says, I know when I get a product, there will be a product object at the address that I have here, but I don't know where it is yet because it hasn't been created. So when you say product is equal to new product like that, this calls on the product constructor to build the object in memory. So it's going to, now what will happen there is that will be the address of these contiguous memory locations. And then, so TV goes in there, 1, 2, 3, 4, and so on. And then you can access, print it, do whatever you want with that. Okay? So that's how you construct it. Now, remember, if you don't say new, there's null is there. So if you don't say null and you try to access an element of it, it will say to you null pointer error, and that means there should be an address here, there's null, and that usually means, well, always means, you haven't done your new product. So you need to do two things. You need to have your declaration and your instantiation or your calling of the constructor. Okay, so again, you can have multiple products. There's no point in having a class if you can't have loads of. There's no point in having a design of a house and you only do it once. Of course, you might do that, but that's a different choice. So here we have a product like we have had before, but now I can have another product called phone, and that has different values in it. They're both unique. They're both unique addresses, and look at that. Okay. So what I'm going to do now is I'll give. We'll come back. It's 12:53 according to that. We'll come back at 1. Just for a quick slide deck on driver. Okay, so I need to use the machine to set up some more things. So I'll just put on this for the moment. All right. Okay, so talk to you later. Hello, and we're back. So for this slide deck, we're going to have a look at the driver class. So we introduced it a bit last week, and we'll do a little bit more about it now. So we're always going to call the class that contains the main method, we're going to call that the driver class from now on. And the idea is that it drives the running of the program. So we'll build it up, we'll be a little bit more sophisticated as the time goes on, but for the moment, it's a very minimum working example version of it. Okay, so we're now looking at the driver class. And as I said there, we'll be using the driver as the name of the class. The main thing here is that it manages everything, right? And it is the only class that should have read-ins and printlns, right? System.out printlns. Now, that's not necessarily during the development if you need to get information back and so on, but at the end of a system. The idea is that if you think about the music system, and we have our amp here, and we have our tuner here, right? What you're trying to do is you're trying to have the least number of decisions every single time. So you're going to have one wire or two wires, the red and the black, be very technical about it, and going between them. And the idea then is all you need to, and it's to do with the interface, right? So at the amp point, right, the amp could, for instance, do all sorts of different things, but all the decision about what goes out to the speakers is coming from the amps. I mean, obviously the data is coming from the tuner, what radio you're on, but how it's actually managed is on the amp. And if you think of that with the driver, we use the scanner at the moment. So that's console output and input, console output and keyboard input. Generally is what we're using. But what we'd like to be able to do is we'd like to be able to have our classes, like our product class here. And we can change, just say, our scanner class here to something much more modern, maybe. And we could put in here, you know, some nice UI way of getting the information out and maybe reading it in as well. But the product won't change no matter how we're getting the information in and out. And that's the whole point of this, what we call cohesive. Now, you don't have to worry about remembering that name, but it means that product does one job. It doesn't decide what your output is going to look like. It's going to provide you with, if you ask it to do things, it'll do it. And then it'll provide, you know, the string version of the product to you in toString. And you can decide over here exactly how you're going to manage that. All right, so that's a big issue with the driver. That's a huge thing with it. All right, and it brings the program together. Typically, it presents the user with a list of what can be done. Now, as I said, the current version is very much a minimum working example, and it's a minimum working example, and you can see how all we're doing is creating one product and printing it out. Like, it's not going to change the world, but what we're going to do is we're just showing you how to actually get the information in, structure it, call the methods of the class, and so on. Okay, so eventually it'll be a nice menu system. Okay, it's going to be console based, just because, we could have decided to do a GUI. We're not doing that. But product would remain unchanged, remember, no matter what type of input-output we were doing. So just look at the scanner class, and I know you've been using this, so we won't spend too long at it. So we're using the scanner class to manage the reading of data from the keyboard. So it comes with Java, and really this is all we need from the scanner, because we just use the system.out.println, which is a standard issue from Java. So this scanner class is part of the Java util package. So basically loads of utilities are in there. And if you're ever wondering, just put in java.util and Java API and see what sort of packages are in there, just if you want to kind of nose around the API. Okay, so to do this, you need to import it here. Now remember that in Java, there's like 3 levels of imports. First of all, there's things like string. And no import necessary. You get that for nothing. There's a couple of packages that come in for free. The one you're looking at, just say scanner. You need to import. And then thirdly, you need to import, we'll call it an XML library. We'll be using this in the next while, where you need to import. And when I say you need to import, that's just using this import here. But in the XML one, you need to import as per number 2. And you also download the library. So it doesn't come within the standard or package. It doesn't come with the standard Java. And we'll see this in the XML. So for the moment, we've used this one. Now we're going to see how we use that one. Now, why is this the way we do it? This is the way we do it because it's the best we can come up with. Okay? What we're saying here is we want to make it as good as possible. String, nearly everybody's going to use. There's a few other ones in the lang there as well. If we allowed everything to be used in this way, then every time you wrote a method or a string, it would have to check every single library, and it would just take up too much time. So what we do is we say, we'll give you a few for nothing. And then, if you need any more here, sorry, that's... if you need any more that are kind of standard, do it like this. And if you need ones that are kind of off the main line, you can do it like this. And we'll show you how to do that when that happens. Okay. So here, when you're using the import, you have this. It has to be at the start of the file before the class declaration. Okay, and this is in my driver. Now remember what we said. Only the driver manages the input output. Okay. Now, having imported it, we want to actually. So it's like string. It's just a class, and you need to make your object from it. We're going to see different ways of doing different input and output, but for the moment, we'll take the simple version of the scanner. So you have a couple of things here. This is like you would have had string like this before. So, you know, you'd have had string, str, and you could have said, you actually, we didn't need to do this, but you could have said new string, okay? Now we were allowed, because string is so common, we were allowed just to say is equal to hello. That's okay for string, it's not hello. It's not okay for most other things, okay? So now in this, what are we doing here? Here, we're saying, give me a new scanner, right? And scanner allows input, as I said, but from loads of different, you can actually define where the input comes from. It could come from a file, it could come from a sensor. It's not going to, because we're saying just bring it into the in from system.in, which is the standard, and the standard defaults to the keyboard. So what you're doing is you're saying, I'm going to, this is going to come in from the keyboard. It's going to be a kind of a standard input-output situation. Okay, so that's here. You can see there that's on the code. So it's private, and again, it's a private field. You're not going to be using it anywhere else. And so it's going to be new scanner.system in. And you could call this input anything you want. Now remember, you can call them anything you want, but I would always say keep it simple. If it's about input, you call it input, and then you can see what it's about. I mean, you could call that apple or orange as long as you called it apple or orange right throughout. Please don't call it apple or orange. Okay, and okay, so these are the methods that were allowed, and so next int will, so you know, you'll have this as your input.nextInt, next double, next line, and so on. So next int will give you back the next integer. The following one will do the next double, next line, and next caret. Now I know somebody had difficulties with the next double. Came up on Slack. Hopefully that got sorted out, because you know they should easily kind of bring back your double and so on. Okay, so they're the ones we use. So for the recap of version 1 then, which is what we've just seen in the previous slides, we have this, the driver, and we have the product class. Now we're going to look at the driver, okay? And the driver has the main method, and we're saying we're going to use the driver to hold the main method. Every program, what I mean by the program, the whole suite of everything, it needs a main method, or it has no way in. It's like the, you know, it's like the setup or the main in processing, but you know, things would work otherwise. Nothing will work without the main method here. So we want to read in the product details, invite the user to send the stuff in, then do the logic, the programming logic to create a new product object, and then print the product object to the console. So we're going to use the scanner to read in the product details. We're going to store these details in a product object. What does that mean? We're going to call the constructor, okay? So here when we say we're going to here, so we're going to create a product object. Using the constructor. Okay. And then we're going to print them out. So as I said, it's a minimum working example. It's not it's not terribly functional, but it'll show you how the thing comes in and comes back out. Okay, so the product we've seen, I'm just going to run through those. Okay, you've seen those, and now the details of driver. So we've seen here, we have the fields. The fields is we're going to create a new product. So this is where we're going to store the information about the product. And then we have our input. This is what allows us to read in from the keyboard. These are our methods. So we're going to have a method, and you can see they're void because, as I said to you, what void methods do in general is there's no return value. So generally, if there's no return value, it has to be some purpose to it. So the purpose in general for a void is to change what we call the outside world. So it changes the state, or it prints something out to the screen. So this is our main program, which is always going to have the same header and so on, the signature. So this is what we want it to look like. We want, now the black is what, the black is what the programmer prints out, one line at a time. And then the user will input that, then that, then that, and then that. Yeah? Okay, so that's what it's we want it to look like. Because we need to allow the user, we need to help the user. Okay, so remember, the product name is a string, the product code is an integer, the unit cost is a double, and the product is in your current line, yes or no, yes. Okay. So how are we going to implement that? Okay, so just to show you that the code is looks very verbose, and there's not a lot you can do about that, okay? So if we look here, we'll see what we're doing with add product. So this is, we'll see this later, right? What you're going to do is, the first thing you're going to do is you're going to add the product. Okay, you're going to add the product. What does this mean, right? Here's my add product. So this add product, this is how it works. Okay. So the first thing that happens is that this is run. Okay. So this is the first line. So on the screen, it's going to come and it's going to say enter the product name. Whoops. And there's spaces here. And the person then, the user, will type the name of the product name in here. So I'll say microphone. So the user will type in microphone. Yeah. Then, only when, so the program will wait for the user to actually type in their stuff, and then when that happens, product name will now have the value of microphone, and then enter the product code, comes up on the screen, and the user will type in a product code. And we'll say 5, 6, 7, 9. And only when that happens will it move on to the next one, where it'll say enter the unit cost, and the user will type in something like 33.98. Okay, and then again waiting the input happens. You're going to say, is this product? It's going to come out on the screen. Product in your current line. And the user will put in yes or no. Say yes. Okay. Now, what do we do with this then? So when this is all done, we now have given values to product name, product code straight in, unit cost straight in, current product straight in. In current production line is different, right? We're not going to ask a user to type in true or false. The user doesn't care about those things. So what we do is, we're essentially going to do this. Okay, so I'm just going to get rid of this just to clear it up. Okay, so in this one, I typed in yes. So what went in there, first of all, was yes, the first character of yes. So that would come in as the character Y, yeah? Just because if I'd said no, it would have been the character N. So what you do here is you're actually trying to essentially say, if that value is Y or capital Y, then in current production line is true. So what that is going to do is that's going to make it true here in this situation. Okay? Now I could do one of two things. I could have said else in current production line equal to false. Okay? But I do it a slightly different way, and you'll find that this happens. So I have that. If I have that, I don't need this. Sorry, yes, I do need the Boolean part, but I don't need to say false. So I would need this, but with no value. Okay? So the red way, if I can call it that way, you can either do this, and we can get rid of that. And we can do this. We can do this. And then that's the same as having means that it's going to be false unless you find it a Y or a capital Y. So there are two different ways of doing it. We tend to do that a little bit. It's quite efficient because you don't have an else involved in it, but it's just another way of doing something. So what do we do then, right? Now we're ready to create the object. Why are we ready to create the object? Because now my constructor needed 4 values. It needed a product name, which is a string, a product code, unit cost, and the unit production line, which needed to be true or false. It needed to be a Boolean. So I'm ready to make that. So now I have my product. The product, the name was, what did I call it? A microphone. The product code was, I think, 2345 or something like that. The price was 32, just say 98, and the Boolean value was true. And that's my product. Okay. So that's to here. So that is what has been involved in add. So what do I do in add? First of all, I get the input. And second of all, I create the object based on input. Okay. And the next, which is a little bit more, it's a little less complicated, but there's a lot going on here as well. So what this does is it says print product. Now remember what product, when I say product here, what it actually calls is product .toString. You could also try writing the toString there. Yeah. You know, the product .toString, the same thing will happen. And remember what that returns. That returns a string version of the object. So when we say print out that string, so that string gets printed out to the console. Okay, that's what it should do. And well, we haven't called it yet, but now hark, we're going to call it here. So here you can see here. Now you can think of this as a way to call the main, and it does seem slightly anti-intuitive, but the easiest way to think about it is that main is a kind of a, you can think of it as a foreign method, okay? And what this is saying is create a driver for me. Now, in this driver, I have 2 methods. In the same way, it's scanner methods, string is methods, and so on. And when I want to call them, I just say driver.addProduct.printProduct. There's loads of different ways you can actually do this. You could have a constructor in it that calls things as well. But this is a kind of the handiest way to do it. But remember, you're creating an object, it looks like you're creating an object inside in the object, but actually you can think of the main as a kind of an interloper. So it's creating a new object outside. It's not part of the driver. And then you're just adding the product and the printing as product. Okay. So this is the input product. This is just a recap. And this is your main. This is your add product, and so on. And that was your print product. So this is what comes out when you're add product. So the enter, remember the order, this happens first and waits until you input that. And then it goes from there to there, prints that out and waits until you type this in. Then moves on to that, prints that out, waits for the unit cost to be printed out, and then does this, again waits, and then finishes up. Okay, so it's like 1, I'll just clear it off first. So 1, 2, the user gets involved there. 3, system. 4, user prints it in. 5, system prints it out. 6, user. 7, system prints that out. And 8, the user types in yes. Okay, that's the order it happens. And if you stop at any time, it's going to wait. So you can see here, I've kind of gone through this, but you'll see here that when you do in the ad, right, this bit is for the user to help them out, and this is calling the read-in. Okay, and this, when you type in 24-inch TV, from there, that value goes into the product code thing. Next, then the product code is in next int, so you're going to pull that in, and you've also put a value into product code. Next double, and that put that value 399.99 into unit cost, and then the next one, if it's yes, that'll actually put in the value of true in there. It's the tricky one on the way in. We will eventually write a utility, because that happens so often. We like a little utility that takes in a yes or no and returns Boolean. But not for the moment, we'll just hard code it there. Okay. And here you're calling the constructor. Remember, product is a public method, it's a public constructor. So you can actually do that from outside. So you're creating that there. And then you're going to print it. So here you've added it successfully, and then you're going to print it, and that's that. Okay, so that's a little bit of code as well, and we just have the validation slide deck to do now. So I wanted to be really kind of comfortable with the driver, and the product. And now in the next slide deck, what we're going to do is we're going to improve the product, because we're going to say we want to control what is coming in here. Okay, we don't want silly values coming in, and so on. Okay, so I'm going to attempt to put up a timer on the screen for you, and we'll say 10 minutes. Okay, and we'll come back. All systems go for the validation. Okay, so bear with me there. Okay, so Siobhan is training me well. I've actually put on the microphone again. Okay, so what we're going to look at now is we're going to, just in one slide deck, we're just going to look at the product class, and we're going to see how we implement validations. What does that mean, right? And why do we do it? No, that's we'll see that kind of as the time goes on. Okay, so just recap again, the driver and the product we've seen. This is the product, and the product has name, code, unit cost, and in the current product line. So, and these are all the product class that we've seen. Nothing new there, and the constructor, and so on. The M that's the constructor, it's public, and so on. This is from the previous slide as well. And this is what we are looking at here. This is the fields and the constructor. Remember, we looked at the encapsulation for that. So, and these are the methods, and we had all these methods, and you can see the returns are never going to change, by the way. That is it with the returns, never change. But the setters will change, and the constructor. So these are the setters, and we're going to put more logic into that. Return type and so on, and the parameter. So in this case, before we do any validation, we just say, here's the value, throw it in, don't even check it. And this is the field being updated or changed. Assignment statement and the parameter value. Okay. These are our setters, all of them. And you can see in all of them, it's a very simple assignment statement. Now, and just to say that we were normally asked to write a getter, a setter, and a toString, and we looked at that as well. Okay, and okay, so when we're entering a product, we went through that in the last slide deck. The system printed out the black, and the user typed in the green, and that was part of the make product thing. And here, what we're doing there is it's inviting the user to enter details of a product, and it prints the details about that product to the console. So that's what the driver does. Now the limitations in product at the moment, in that we're doing all this setters and getters, but actually it's not giving us any benefit, because we don't use the code in the setters to check, or in the constructor to check, is there anything wrong with the data coming in? So one thing about the errors that come in, just to think, so if I have the product, right, and or sorry, we'll say the product name, right, or the unit cost, we'll say, right? Now this is a double. Okay, that's the double. And okay, so if you put in as a user, right? If you put in the value of 35, okay, put in the value of 35, and it should have been 36. There's not a lot we can do about that, okay? Because they're two reasonable amounts. However, if you put in 35 and 36, 35 is going to go in because there's no way, right? So this is the amount you want to put in. If you put in minus 36, you should be able to say, hold on a minute. It's not possible that the unit cost of something is minus value. And that's where we start coming up with our validations. Okay? So the validation, a reasonable validation for unit cost would be that it has to be greater than or equal to 0. Okay? Greater than or equal to 0. So we'll implement that. Okay? Then, just say for the, in the name, the product name, whoops, the product name, what we're going to say is that the length of the name should be just say less than or equal to 30 characters or 20, whatever your thing is, right? And you want to implement that as well. For your product code, that's an integer, and we'll say maybe we want it to go in a range, some range from a min to a max. Right? So maybe 1000 to 999. For instance, if you wanted a product code that had 4 characters, that's a way of doing it, inclusive. Okay, something like that. Now the Boolean, interestingly, you don't need a validation on Boolean, because if you put in a Boolean, if you're sure it should always be true, then you don't need to input it as a parameter. So it's either true or false. There's no validation on that. Okay, so we're going to have different kinds of validations then, depending on the field. Okay, so here, in our case, I just want to run through this a little bit more quickly. So for the purpose of the app is to read in a product, perform calculations and updating it. We can either add it or update it, right? We haven't the update written yet, but so what we're trying to stop is preposterous values. So what we're trying, if you remember the garden, right? And all the lovely flowers. I'm not even going to pretend to be able to draw flowers. So what you want is you don't want to put up big fences, but you want to put in a gate so that only certain methods come in, all right? So the methods that are allowed, these are all the public methods. So this, like your setter, is like, what do I want to do to the flower? I'm allowed in with water or a strimmer, even something like that, right? So we can do a lot here, in here, because we've got our way in. So what we're going to do is we're going to say, then we can think of our data, and we can think of your name, code, and so on, whichever they are, right? You can think of these, and what you can think of the setters and the constructor. These are like the last line of defense, okay? These are the things that control how these are being updated. The getter, now remember, only kind of takes a photograph. But these are going to control any update that happens. As I said, if you put in the wrong value, there's nothing you can do, like if it's 36 instead of 35 or the other way around. But if you put in minus 36, you should be able to know that. So what we do is we examine the spec or the system and see what are reasonable validations for each of these fields. Okay, so sometimes there could be max and minimum and max, like for the product code, and a default value if those are breached. In the case of the strings is an outlier, so we're going to do that kind of differently. But for here, for a number, we have a default value that basically if we try to set up an object with an invalid value, we put in that default value. Okay, so that's in our constructor. So we have a few different ways of doing this. But first of all, we're going to just run through kind of reasonable kind of defaults. So the product name, the length of the string is 20. So we're saying anything after that we don't want. In the default then, in the constructor, if the product name is longer than 20 characters, we truncate it to 20. So we can do that by just doing a substring 0, 20. All right, on the whatever the product name is. Dot. Okay, now note that this is an outlier. That's very important, right? In the constructor, we generally don't have an else. So in this case, you either put in the full value, or if it's greater than 20, you chop off the first 20. Okay, so that's the string, and that is an outlier. Product, if I'm saying that the product code is between 1000 and 999, then in the constructor, if the value I try to put in is outside of that value, I default to 999. I tend to put, you will put a default at the extreme so that it's kind of obvious. And just note that this is a nice way of ensuring the 4 digits. Unit cost, a reasonable thing would be to say that it's non-negative, or in maths terms, greater than or equal to 0, and the default value then is 0. Because if you have something unit cost 0, what you're trying to do is give it a value that makes it obvious. And then, as I said, there's no validation required. Okay, so that's what we want to do. We want to stop anything with the length of more than 20 going in here, anything with a value outside of 1000 to 999, anything here that is negative, and we're okay with this. We'll take anything we're given, we'll take there. Okay, so the default values then. So we've a new way of doing this. And what we're going to do is, if you remember when you were declaring integers, there was a number of different ways you could do it. You could say int x, and then x is equal to 10. Or you could say int x is equal to 10. So you do the two things together. All right? So what we're going to do here is, when we declare the variable, you can see there's nothing here, right? We just declare them. We're actually going to say, here are the default values. Now, product name, we put that in just to give it a start. These are my genuine default values. False is there. Not so useful, neither of these, because we'll be giving them the values. But these ones are very useful. Okay? These ones are very useful. So these are the default values. That's how I do that. Then I'm going to implement the validation rules. So I'm going to change the set product code, which just threw in whatever we got, right? Now remember what this is doing, right? This product code goes in here. Now with no thing, it goes directly into the field, and that's the field value there. Here, we're trying to check, is this product code a valid value, right? Now, there's a number of things here that you need to concentrate on. So you check, is it between that and that? So remember, we can't say, in maths, you might say x is less than or equal to 10, and is greater than or equal to 0, something like that, okay? Or in this case, okay? You can't do that remember, in the Booleans, you need separate, well-formed conditions in both case and them together. So you need something to be greater than or equal to 1000 and that, okay? So when you've that done, what you're doing is you're saying, I'm only going to set, right? This is really important, right? Only make the change if the value coming in is valid. What does that mean in programming terms? What that means in programming terms is we have no else. No else here. We're never going to have an else in setters. In some other, in some other systems of programming, you might have an else in set. We're not going to have an else in a setter. Okay? So for the purposes of this semester. So we only change if it's valid. Okay? So that can cause issues, but we'll deal with those. Okay. So now we also want, any time that the field can possibly change, we want to do that check on it. Okay? So now in our constructor, and this is where we get the benefit of the setter, we could have written here our if, we could have written here, instead we could have written if unit cost, then or greater than or equal to, and unit cost, so on, as we had before. This unit cost, we could have done that. But what we're trying to do is, we're trying to say that we don't want to repeat that code. Okay, because we've already written this. So instead of writing that, we call the set product, which had the same logic in it. And that's the key to what we're doing here. Now, we only use the set product to change if it's valid. So what happens if it's invalid? Well, that's where the default comes in. And because the default will have been, whatever that was, 9999, okay, if the value coming in was not valid, it will leave it at that value, okay? Unit cost is going to be very similar. I'm not going to spend too long on it now because we're coming out of time. So have a look at that. This becomes that, all right, in the setter. Again, we're going to have the same idea. The unit cost, just throwing it in the constructor, will have a setter. Same idea. Product name is different, okay? In the setter, we want to say the length is less than or equal to 20. If it is valid, change it. But in the constructor, and this is an outlier, in the constructor, you do need to do this because I need an else, because in this unusual situation, there's no pure default value. If it's greater than 20, I just want to use the first 20 of it. So it's still valid, but it's based on what's there. Okay? There's no need for validation in the current product line. And boundary testing. So here, these values, what we want to do is we want to have values. So we want to check, remember, this is invalid and this is invalid. Yeah? These are, what you're doing is, if the range is between 1000 and 9999, you're going to check just on the edge, just below the edge, and at the upper limit, on the edge and above the edge. And then here's some normal value in the middle. Okay? And do the tests on this. So you might want to call the test on that, just using the setter and seeing has it made a change. We'll be doing this in a more structured way later, but just convince yourself that the setter is correct. For product code, add a new product with the value of 999. Then the default value should be, because that's below the mark. So you should, when you get it printed back again, it should give you 9999. Just inside, add a new product which valid, and you should see that that'll come out as went in. Inside the range, 2000, that's the normal one, so that should come out as is. And add a new product with 999. This is on the edge, but it's still valid, so that should be accepted. And then try this, and the constructor 999 will be stored, and for a setter, the previous values should remain unchanged. Okay, check the other fields and make sure you're comfortable with that. We will be using automators to do that later, but there you go. Okay, so that is it. Sorry to have gone over a little bit today. So there we go. There's what's described as my head. So listen, thanks a million, and we will. Yeah, sorry, it glitched there. There's comprehensive exercises on those. I need you to make sure you're okay with those, because from now on, we'll be assuming that you're okay with validation. So break it down, make sure you're okay with each of the fields, and practice it. So the two exercises, one of them is just changing the validation rules so that you can see what you need to change. And the other one then is a brand new one where you're asked to implement other stuff. Okay? So we're saying we went through a lot. The validation is the rest of it is kind of recapping. So for Wednesday, which is our next meeting, we'll be looking at using the arrays that Siobhan went through last week, and we're now going to have an array of products. So instead of having an array of integers, we're going to have an array of products. Now, the thing is, from now on, we're going to take that fully formed product in the fully validated product, and we're just going to use that validated code all the time. So even if we have an array of products, every time we create a new product, or every time we try to change an element of the array, those validations will kick in, and that's the whole point of it. All right, so thanks a million for your attention. Sorry for going on a little bit too long, and as usual, make sure you will get onto Slack if there's any issues and so on, and nice to see you. Okay, thanks a million, folks, and we will see you on Wednesday.